It's the stuff of bedtime stories. In the beginning, there was darkness, then came light. And that light shone out into the blackness and pushed it back. But is there anything more to the story, like what came before the light, or how did it start? Well, astronomers are looking deep into space to find out. What they've seen so far has surprised them, and they think there's still more to discover. This is cosmic dawn, the period when the first stars and galaxies formed and ended the cosmic dark ages, giving way to an era of cosmic enlightenment. It's one of the most exciting periods in the history of the universe, but also one of the least understood. We know that because of how fast the universe was expanding at the time, only the very largest stars could have formed. They would have been up to 300 times the mass of our Sun. And we know that these first stars exploded in spectacular supernovae, blasting their outer layers into space and seeding the universe with the heavier elements. But the details remain a mystery. Well, almost a mystery. Scientists recently reported the discovery of a strange object that might be a relic from this dramatic period. Let's rewind about 13 billion years. The universe was dark. There was no light and hardly any matter. Most of the matter that would eventually condense into galaxies was floating around in wisps, filling the vast emptiness between exploding stars. These wisps of matter are called nebulae, and they're mostly made of hydrogen and helium. They're kind of like the building blocks for the rest of the universe. As the universe expanded, it was cooling, and the matter inside it was slowly coming together in larger and larger clumps. But why it started clumping together like that, and not just floating around forever, is still a bit of an open question. And the answers will come from the James Webb Space Telescope. That was until recently known as the Next Generation Space Telescope, but now known simply as Webb. This telescope was designed to see things to far away for the much older Hubble Space Telescope. It launched Christmas Day last year and arrived at its destination, a spot called Lagrange Point 2, in early February. After a few months of getting into position, calibrating its instruments, and taking selfies, Webb has begun its science mission. The telescope has for instruments that can see invisible, near-infrared, and mid-infrared light. Infrared is useful for looking deep into space because stars and galaxies tend to redshift, meaning their light gets stretched as the universe expands, shifting them toward longer infrared wavelengths. Webb can see farther and in more detail than any other telescope, so it is going to help us peer back through time and learn about the universe as it was in the days just after the Big Bang. And what better way to inaugurate the new scope than by looking at the dawn of the universe? In a paper published June in the journal Nature Astronomy, astronomers reported the results of one of Webb's first science projects. They used the telescope to look at a patch of sky called the Sapphire Star Factory, which contains several young star clusters. Using the NIRCam instrument, they looked at light from a wavelength of 1.2 to 5 microns. At these wavelengths, the universe becomes transparent. We can see through dust clouds and look at things we wouldn't normally be able to see. In this case, they were looking at the glow from gas clouds heated by nearby young stars. The researchers wanted to study these gas clouds because they thought that they might have a population of ancient carbon-based molecules called polycyclic aromatic hydrocarbons, or PAHs. Astronomers think that these molecules play a critical role in the formation of stars and planets. They seem to absorb ultraviolet radiation from young stars and then remit it in the infrared. That makes them a good candidate for lighting up the darkness of the early universe and triggering star formation, and Webb found them. The telescope saw PAHs around young stars in the Sapphire cluster, confirming what scientists had long suspected. Stars in the early universe would have formed in a similar way to stars today, gathering together out of giant molecular clouds. And these molecules may have played a key role in that process. But that wasn't the only surprise. The team also found a lot of water in the form of ice grains. These were present in gas clouds around young stars that were up to 8 times the mass of our Sun, and the team was totally blindsided by this finding. No one expected to see this much water so soon after the Big Bang. Ice is defined as any solid that has enough free space between its molecules for water to flow. So while we think of ice as cold and frozen, in space it's really just water vapor at extremely low temperatures. Since the temperature of the gas clouds around these stars was around 1000 kelvins, about 700 degrees Celsius, that meant the ice grains had to be extremely small, less than 100 nanometers across. The only type of ice that can exist at those temperatures is amorphous water ice. Most of the water in our bodies is in the form of H2O to hydrogen atoms covalently bonded to an oxygen atom. But the team thinks that the conditions in the early universe weren't right for this type of ice to form. Instead, they think the water molecules were bound together in a random arrangement. Hence the amorphous ice. They don't exactly know where the water came from, but they have a few ideas. It may have come from comets or other icy objects that formed in the outer solar system and then got blasted inward by a nearby supernova explosion. Or it may have come from gas that was already in the vicinity. If that's true, it would mean that water must have formed in interstellar space fairly soon after the Big Bang. Either way, the fact that this happened so soon after the Big Bang suggests that wherever there are stars, there is water. And since there is water, there may be life. Well, maybe. Okay, so Webb found water, but what about those mysterious objects from the beginning? In another paper published June in the same journal, astronomers reported the discovery of one of the most distant galaxies ever seen. The galaxy is called Glass 13, and it is so far away that its light has been red-shifted out of the visible range and into the infrared. What makes this galaxy special is that it existed just 340 million years after the Big Bang. At that time, the universe was so young that the light from this galaxy hasn't had time to reach us yet. What we're seeing is a baby picture of the early universe. The thing is, the team doesn't think this galaxy is just a galaxy. They think it might be the remnant of one of those huge population 3 stars. Over time, this stellar corpse would have lost most of its gas and turned into a giant blob of iron and nickel. That would explain why it's so small and faint. It's not a true galaxy, it's something left over from the first stars. These objects are hard to detect because they don't emit much light, but Webb should be able to see them clearly enough to analyze their chemical properties. That will tell us a lot about the life cycle of the first stars. And that's only one of the secrets that Webb is going to uncover. For example, we want to know what black holes were like in the early days of the universe. Researchers are eagerly anticipating Webb's first image of a supermassive black hole. This will be a snapshot from when the black hole was just a baby, weighing less than 1,000 times the mass of the Sun. We'll get to watch it grow up before our eyes. All of this will tell us more about how we got from nothing to everything. And it's just the latest chapter in the search to understand the origins of our existence. All of this because humans are naturally curious creatures. We want to know where we came from and what we're made of. And now, thanks to Webb, we will. If you enjoyed this video, you can watch another one about dark matter here or another one about black holes here.